All right. So it looks like we're live again. So welcome to HardlyBrief Dev. Today I'm going to be working on our inventory system, but I wanted to review where I left off with the gathering system, some of the updates I have on the inventory system, kind of just give an overview of where we're at. In the last live stream, I was working on creating a gathering system. It wasn't going too well, so I went back to the drawing board and kind of rethought how I wanted to run everything. And I made some good progress on it and have some good bones, and I'll run you through my design. And then I also have worked on my inventory system a bit more, and I wanted to show that off and kind of talk through some of the issues I ran into with Unreal Engine and how I fixed it. So we can start with the gathering system. And I'll talk through the structure of how I designed it, because I think it's a pretty good design, that it's extensible and I can add more functionality and features later, which I think will be good. So again, this is the mural that I have set up talking through the things that I'm working on. I'll post that in the chat. So if you're interested in what I'm working on, here you go. And with that, I have down here a high-level zone management architecture that I'm calling it, my design, my thought process. And let me lock it all just so I don't screw it up. But the idea lies with having a central zone management subsystem. So a subsystem is, there's a whole bunch of different types in Unreal Engine, but in this case, this is a world subsystem. So it gets instantiated or created when the world is created. So in my case, when I press play, we're creating a world, the large persistent world for the server. And so we're going to create a world subsystem called a zone manager subsystem. And the idea is every zone will have a zone manager actor that controls all the things that are happening in that zone. In the first instance would be a gathering manager that runs all the gatherables that are part of that zone. So think a chest, fishing node, herb node, or mining node. Those will all belong or be managed by the zone manager. The zone manager will be managed by the zone manager subsystem. So the way this works is when the zone manager is created, all the zone manager subsystem is created. It sits there and it waits for registration by all the individual zone managers themselves. So when the world's created, and I can show you inside my hierarchy here, I have a zone manager object. This actually calls to the subsystem and says, hey, I'm alive, register myself. And then we store that manager inside a map. And it's all based on a zone tag. So you can see here my zone manager has a zone manager zone tag. So I'm saying this is Eastern Kingdom's Elwyn Forest zone. And we can have tons of these, all controlled by this subsystem. Now, as a designer, when I want to add gatherables in my world, those are going to be controlled by an actor component, which with the structure, this means I can add all sorts of features and functionality to each zone individually just by implementing different actor components. So if I want a zone to have gatherables, again, that's like chests, fishing nodes, herbs, mining nodes, that sort of thing, then all I need to do is add a gathering manager component to my zone manager. Then I can go around and place the mining nodes in the world. So if I come back into Unreal Engine, I actually created 2 mining nodes. They're copper nodes. You can't see them because I have the mesh turned off. But if I go into my visibility of the mesh, I think I can turn it on. So you can see it's just like a small tone, nothing too crazy. And I can add it back to this one just so we see them in the world. So we have these 2 mining nodes. These register themselves with the zone manager, and then the zone manager is responsible for, or the zone manager gathering component is responsible for how they show up in the world, and that sort of thing. And all that's data driven, meaning it's all managed by data assets or primary assets. So if I go into gathering, well, first and foremost, my zone manager is also managed by some basic data. But if I go into the gathering and we see the data I've set up for my my nodes, we can check that out. So every gathering component has has information on the what's required for gathering. So again, gathering is all those things I mentioned prior. So the first thing is we have a minimum and a maximum active number of gathering nodes in a zone. So this is like total nodes, meaning ramps is stage. What does that mean? What is ramps is stage fill? Anyways, so I have these different, I have a map here. I can add more. So if I wanted to add chests or herbs, I can go ahead and say herbs, and then I can go ahead and do the different things that I want. I can say I want a minimum of this type of node and a maximum of this type of node. So just basic data driven through an asset. And I can show you the code for how this works. So let's go into my project, and we'll take a look at the zone management. So here I have a zone subsystem. The zone subsystem again is a world subsystem, and on startup, the only thing this thing does is it sits and waits for zone managers to register themselves so far, and then I created a helper function to get a zone manager by a specific tag. So nothing too crazy in here. There's also an event that gets broadcasted every time the zone manager is registered, and that's for all the different nodes in the world to listen for. So if I'm a node, I can just call out to my get world / get world subsystem node and get the subsystem that exists here, and then listen for this event, which is nice. So then we'll go into our zone manager. So this is an actor. It is a non-replicated actor, meaning that this just sits on the server. We don't need to see any of these zone managers in the world itself. And these are pretty simple. That just has initialization and a zone tag for now. The real functionality and features comes from the components. So I created a zone gatherable component, and this is really what manages all the zone gatherables on the zone manager. And again, the idea is I want modularized pieces so that I can put them on my zone manager and customize what every zone is like. So in this case, the behavior here is I want gathering. And the way these work is that it has a data asset. This data asset defines how the zone allows gathering. So the total number of nodes, we could have spawning logic in there, we could have rarity, that sort of thing. You add the behavior defined in a data asset that this component will then use to understand how it should spawn and activate nodes. So let me go into that file, and we can talk about kind of some of the logic I have in here. So first, when through a interface, a node can register with the gatherable component. So we just check to see if the zone exists, or if it's valid. If it is valid, then we're going to add it to our all gatherable nodes array, and then we're going to try to activate that gatherable node. Inside that, this is where a lot of the magic happens. So inside try activate gatherable node, gonna again check to make sure the node is valid and make sure our zone gathering asset, that data asset, is valid. If they're not, then we can throw an error. From then, we want to check to see if our active node count, how many active nodes of all types, so mining, chess, fishing, herbing, exists. And if that number is less than the greatest amount, or the minimum amount, or the maximum amount, we want to make sure that we always have nodes available in our world. So that's why we have that minimum and maximum, and we don't want to just have thousands of nodes, because then there's just too many for the character to run into, and I think there needs to be some form of scarcity of these nodes. Once we do that, then we try to get the gatherable type. So what type of node is this? That's just to ensure, because we have different types. From there, we check based on that gatherable node type. We check to see what that type allows. So in my zone, I can have a total of 1,000 nodes, but I might only allow 25 mining nodes. And so this is that check here. If we do that, then we have some specific node specific data, like its spawn chance, how often it should spawn. So we have a spawn rate, We check that, and then if all that's true, then we can go ahead and activate the node, which we'll go check out what that is in a second. So when we activate the node, we're just turning on the visibility of that node, and then we're adding it to a active gatherables nodes array so we can understand which nodes and how many are actually active. So if we go into our node, that's kind of a more interesting actor. That's the one that's actually replicated. So I'll go into gathering. Let me pull the actual header file up. So here I have a gathering node. This is a actor, and it is replicated. And the only thing it really has right now on it is a mesh component, which we deactivate and activate from the server. And it has a zone tag. So what zone does this node belong to? And this zone tag is used so we can find the proper zone manager that it belongs to. It also has a zone gathering data asset, which I'll open this up so we can kind of view what that looks like. I think that's important. This is what dictates what the mesh looks like, its rarity, what it could have a loot table, spawn rate, that sort of stuff. And then you see we have an onReplicated variable is activated. This is a true or false value that gets replicated to the client. We have some helper functions in here just to get the gathering type, its spawn rate. This just does it to check to see if our gathering asset, which is that data asset that we have, is loaded. In my data asset for the gathering node, each gathering node has a gatherable type. I'm not sure we actually need this anymore, but I've left it in there for now. It has a node mesh, so like what does this gatherable object look like? Is it a mining node that has tin in it, or ore, or copper, that sort of thing? It has a spawn rate, so this is like a rarity rate. It goes 0 to 1, 1 being it's available all the time, it will spawn every time, and then lower percentage, obviously, like towards 0, the less it will spawn. So like if you have gold or silver or some sort of rare material, you would lower the spawn rate. Min and max use, this is state management. So as the node spawns, it can be used for a certain number of times. Minimum 1 time and maximum 4 times. These are just default values, but obviously you can adjust these. And then I have this concept of use chance drop-off modifier. I don't really love the word, but the thought here is every time I use the node, there's a chance that this increases that I won't be able to use it again. And that's just because we want some randomness in the number of times that this can be used. Okay, so let's look at the C++, the CPP file. So on startup gathering node, we set it to replicate. We don't need the tick function, so we turn that off. I do create a default sub object, which is our mesh component, and we set that as our root component because this is just really a visual item in the game. So far, I do not have interaction system set up. I have a very rudimentary one, but I need to expand that, and that's probably something I'll work on next. But the real meat here is on begin play. We're going to look for our zone manager subsystem, and what we'd like to do is either subscribe to the on zone manager registered event that gets fired every time a zone manager in our zone actually gets called or is created, or before we do that, we want to check to see if the zone manager for our zone type is already created. So what we're doing here is I created a interface that allows me to just check to see if that, to allow me to register the node through an interface. But what we do is we say, zone manager subsystem, get me a zone by that zone tag. So I just check to see if that zone manager exists. If that does exist, I'll register my node and then we'll return. We don't actually need to listen to this event. But if the zone manager has not been created yet, this node is going to register to listen for the subsystem to broadcast that the zone manager has been created or registered, and then it will do its thing. When that happens, it's just going to unregister itself at the end. Pretty simple. Hopefully that makes sense. I know there's like a lot of going on in there. Again, it's replicated, so we're replicating the is activated node Boolean value. Here I activate the node, we set that to true, and we can actually on the client implement some functionality that I'll show you. If I open up one of these copper nodes you can see I have the on rep activated node set up to allow me to make it blueprint implementable. I can implement the functionality in blueprints, which is nice. So I just put a quick delay on there, and then I just set the visibility of that mesh component. All right, so I set all that. Let's look at one more thing before I jump into, I can press play and I'll show you how they spawn. It's super simple. But if I go back into my nodes, gathering, my data, I can go open up my copper ore. You can see I just have it set to a cone. The spawn rate is 0.85%, or 85%, excuse me, and you can use it 1 to 4 times. Pretty simple, nothing crazy. If I press play, we can see that those nodes have spawned, or excuse me, that's because I turned them on. We turn them off. I need no 2 mesh component. All right. So both of them have spawned. I can actually go into my logs, and I set up a gatherables log. So you can see that they both were listening to the manager subsystem, and then they both activated themselves based on what the subsystem said to do. I also set up a custom log for my zone manager. So if I go into my zone manager, I can see everything that's happening. Listening to the zone manager subsystem, we have total nodes in L1 forces 1, and then the other one comes online. We have total nodes in L1 forces 2. This just shows us that we have both going. So, for all intents and purposes, this is set up. The gathering nodes are set up. Basic functionality, I have a way to scale up and grow and add more features. So I said, okay, you know, I'm good on that tangent. I don't need to continue doing it. So the next thing I wanted to do, which I think is the more interesting thing, is the inventory system. So I have a slot-based inventory system set up. I'm going to press play, zoom in a bit. You can see I have my slot-based system set up. And I have 2 bags available. And if I hit K on my keyboard, it should spawn in another bag, a small bag, right? So I have my bags available. This is just another item that I gave myself. So before I had created the replication and stuff works. I can show you on my player state, player inventory. You can see my bag slots. So you can see that we have bags in 0, 2, and 4. We have those bag slots there. You can see if I click on the bag itself, that each bag has an inventory. So if I go to bag slot 4, which is this one, we can go to the bag and we can see the inventory, and we see that we have 4 items in that inventory. And before I had broken drag and drop, but I have that set up now, including swapping. So I can click and I can drop an item. And purposely, I have the delay set so you can see that there's a big delay. And I think this is important. When I was dealing with replication, I was like, wow, this is a pain in the butt, that like, why is this delay so high? It's not high all the time, but sometimes you see that it's like a good second or two. And when I was reading online, it was like, well, everything, I thought I read that everything runs at 100 hertz or 100 times a second, which is insanely fast. So I was thinking I was going to have to add client prediction in here, but that's not true. It's a much more simple fix. So if I actually go to my player state object, which is where I have my player inventory actor component on, if I click player state here and I type in net update frequency, we can actually see that I'm updating to the client 1 time a second, which is not that fast, especially for UI. So what I'm doing now is I'm updating this to 5. So 5 times a second, and honestly, I could probably do even 3. We want to keep this as low as possible so we're not bombarding the client with a bunch of information. So I can set it to 3. 3 and 5 seem to work. 4 is fine too. What this will do is it's going to replicate to the client the changes much faster. So if I press play, I go back into my inventory. I can now click and move the bread much faster, which is nice. Let me deactivate my target. So it feels much more smooth, and I can move my items around. And if I close my bag and open it, they stay the same. I can also move items between bags, right? So if I move it up here, it works. close it. And it's all server authoritative, meaning I can't just go in and move whatever I want and it not stay the same. And it take hold. The client doesn't have permission to do that. It's all backed by the server and server item references. The way this works is every time I make a change, we update the backpack. I have it set up to just refresh the entire backpack UI. That's not good. I would like to eventually set it up so we just refresh the individual slots. And I have the data being replicated to do that. I just haven't implemented it. The other thing I have in here is swapping. So like I can click this one and swap it. And that works as intended. And if I hit K, I'll add our new bag and I can move stuff into it as well. And then I have sound effects added too. So that's kind of where I'm at with the inventory system. I have a few things that I want to do on this. If y'all have any questions, please let me know in the comments and I will try my best to answer them. But there's a few things I wanted to work on today and I can talk through the code. So let me open back up my code and we'll take a look at it. So okay, so everything I do, I try to do, like the inventory system is a actor component. And actor component is responsible for managing our player inventory. This is where I have the server functions. This is where I have, let me open up the header file. I'm gonna walk you through this code. So the player inventory component is responsible for all of our bag slots. It's responsible for adding items, swapping items, moving items, that sort of thing. It's a pretty beefy class or file, and as it gets bigger and bigger, obviously we're going to add a lot more functionality. So maintaining the size of this has been challenging. This client RPC is not actually used anymore, so I'm going to write a to-do to remove to remind myself. I was playing around with client RPCs in this case because I thought I needed that instantaneous replication, but it was really just because my player state wasn't replicating fast enough. So all this is built on this actor component, and then I leverage a whole bunch of U objects in the meantime for my items. So I have a bag item, which actually inherits from my U item, which I'll open this up. U item is my base item. It has a name, an asset associated with it, and a quantity. Quantity is like how many of this item exists. The asset has all the information, icon, description, stats, that sort of stuff will be in this base item asset. And then it has a whole bunch of helper functions, initiation, initialization, how do I initialize the item, a bunch of helper functions for me to get different information out of my asset. Pretty simple. The bag item implements that same thing because we want to know it's a bag. We want to know that it has a name, rarity, all that stuff, but then it also includes more things. So it includes an array of items. So when a bag is created, it has a size, right? So 1 to 6 slots or something. And I store all my U items inside this inventory array. And then I have a couple replicated variables to maintain what I'm doing with this bag. Some of these I might not need, like the max slot count. There's some stuff like that I probably don't need to replicate. I can just grab from the server, but I'm just replicating them at the moment. So yeah, so inside the bag is what handles all the inventory. Again, both of these U objects are fully replicated. The way I handle that is by my player. So when you replicate a U object, it needs to have a replicated owning actor, and I do that using this replicate using registered subobject list set to true. This is crucially important because if I don't U objects don't replicate out of the box themselves. They have to be set up to replicate. So in Unreal Engine, you have actors. Those automatically replicate. They're already set up for replication. U objects are not. They need a little bit more functionality. And again, they need an owning actor to do so. So we use this subobject list. So if I go into some of my functions here, I'll show you where I kind of add it. So here we have server add item. if we try to add the item is true, meaning we've added the item to our inventory, we need to add the replicated object, that item, to our sub-object list. That means that item will replicate to the client, to the owning actor, or our player in this case, because the player inventory component is attached to our player state. The other thing that's crucial here is I have replication set up for the owner only, meaning we don't care to replicate to everybody. We only want to replicate this to the owning character or owning client. That's important because if you're replicating to everybody, everybody's going to know what inventory I have. And realistically, at least at this point, no one cares what inventory I have. It's just I care about my inventory. We might need to do something like this if I add trading between characters later, but in the meantime, this is okay for now. Okay, so where I've left off basically is this server move item implementation. So when I move an item in game, let me go back to it. When I move an item in game, we are moving between bags and bag slots, and so I need to like pass in that information. So every time I move an item, I'm sending the bag slot ID, and then the bag item slot ID, and then the bag index, which you can see in this server function. So in this server function, right, we're sending the original bag slot index and the original or the origin bag item slot index, the same where we're intending to go. Inside here, we check to see if it's valid. We get the objects themselves, the bags. We check to see if they're valid. I like doing a lot of early returns so we don't have to do a lot of logic if it's not working properly. I created a helper function in my bag object to get the item at a specific index. If this item doesn't exist, then we know the item that we're trying to move is not valid and we don't want to attempt to move it. Here we have our move logic, and this is where I need to refine and work on a bit today. Ideally, I want to move this out, which I had created a move item between slots function all the way down here at the bottom. I was running into some problems with that, so I kind of dumped it. But ideally, I want to look at how we can kind of refine this logic and move this to the bag. So what I'm doing here, I'll talk out loud, and then again, if you have any questions, let me know in the comments. But we have my origin bag, and what we're doing is we're setting the item, the position of this bag to this item. So this is performing the swap. Whether it's a empty item, like a null item to a real item, or an item to item, this performs a swap. So again, we have swapping working, but I can also just move to a slot. And what's happening here is that it's just trading this item to a null pointer, or this item to this item. So this performs a swap. This sets the origin slot to this performs a swap and this performs a swap. These are actually swapping the item. What we're doing here is we're setting a value inside our origin, our bags, that replicates, that then performs an event, telling me which slot we just manipulated. So last updated item slot index, if we go to our bag item, we can see that this value is replicated to the client. It starts as -1, but as soon as this changes, we actually create an event, or we use this onReplicated item inventory event, this on item added to bag event, and this index to tell the client which bag and which item slot in that bag was changed. That way I can create a function in Blueprints that says, hey, this slot was changed. We don't need to update the entire bag. We just need to update that one slot, which we need to also add. What I'd like to do, though, is I don't like that I'm setting these values in here and that I'm setting these here. I feel like I should be able to say origin bag dot add item at index or something, where we then pass in the item that we want to add and the index. So inside my bag item header file, I think I'm going to write this function. And we're going to say void add item at index. I think we need to provide a uItem pointer and an int32 index. We'll just say index. I think that's what I want to do. We'll say add item to index. This is going to take the original slot index, and then we can pass in this value here. Oh, I did this wrong. All right. So that replaces this. We need to add this functionality. So we'll come in here. What we're doing is we want to say item inventory of index is equal to item to add. We want to check to see if, no, actually, I was gonna say we want to check to see if it's valid, but we don't care, because if it's null pointer, it's fine. We're just replacing them. And then what we want to say here is say last updated slot index is equal to index. Now, there is one problem in here, I believe, that we're going to run into when we start stacking, but we'll adjust that in a bit. So now that we have this and we've replaced it, we also need to do the same thing here. So we want to say destination bag dot add item at index. We want to pass in the destination item slot index, and then the origin item. I might swap around how I did that. So now that we're doing this, we can remove these two. I'll comment those out, and then I'm going to rebuild, and we'll test it out. It should be the same thing. Nothing should change, and then we know that we've added this helper function. It should be the way, but you know, it might not be. We'll let it rebuild. But if that's the case, I think this is better because now we're adding the logic that we want into the bag. We shouldn't just be adjusting the bag's inventory out however we want. I think it's safer to do through an actual function. In reality, we could also add like a log in here. We'll set this to verbose. We'll say item has been added. Item added to bag at. And we could do, we'll leave it like that. Okay. Let's press play, see what happens. Yeah. Exactly what we want. So super simple. It's just that I wanted to remove the, I wanted to move the functionality of this into the bag. I think the bag should be adding the item and not the inventory. Like the inventory should call it, but the bag should be responsible for doing it. So just a little cleanup. There we go. Now, this functionality can be moved to a move item between slots, and we could return a Boolean value that says true or false if it occurred. That might be something we want to do. But we'll have to look into that in a little bit later. All right. Now, I know there's another problem in here. that's probably a pretty easy fix. If I click and drag on an empty slot, we're getting some issues here. We're detecting a drag, but we're trying to access a value that doesn't exist, and that's not good. So we're going to fix that. And I can talk through how I do the on drag functionality in the project as well, which I think can be challenging. So I have a backpack, which just is a container for all of our slots. So I have a couple things. We initialize our inventory, which this function here in Blueprints just creates all the empty slots. All my slots are bag inventory slots. So if I go into content again, Northshire inventory, we can look at bag inventory slots. This is what it looks like, the widget. And the way this works is on creation, we set our player inventory component. We need reference to that. What's happening on drag detected, though, is we're assuming we have access to this item ref here. So what we really need to do is, because this isn't true all the time, when the item slot is empty, our item reference does not exist. And we're trying to access that item reference at a point that it doesn't exist. And then we're still attempting to do all this. So what we can do is just hold control, click and drag, convert this to a validated get. If it is valid, then we'll go ahead and do the rest of this. And we can just drag this down and remove this reference. This way, we're only going to attempt to drag an item when our item reference exists. Otherwise, we shouldn't be dragging. Pretty simple. So if I press play, open up my inventory, we can now see, if I go back to my message log, output log, we're not getting that error anymore because we can't click and drag anymore. But that works. All right. So I created a to-do list. We fixed the error. We cleaned up the swapping code. We cleaned up the bag code. Now we want to look at stacking. So if I go to my item definition, my item definition has a bunch of information in it. But at its core, it has a name, a description, an icon. So bread here. It can stack, has a variable, a Boolean value to stack, and then it can stack size up to 10. I also have a weight value and then a weight float value. So if you want a weight-based inventory system, you can do that, like in Skyrim. And then I also have a value here that is a float value that represents, in this case, in this project, gold. Gold, silver, copper, like World of Warcraft. So 0.05 is 5 copper. That means each bread is worth 5 copper. And I can show that if y'all want. Just let me know in the chat or in the comments, and I can show it on a different live stream as well. But this is our item. This is the base item. We have more details, item rarity, what the item type is, if it's food or not, drink, container, that sort of thing. Equipment type, this is not a piece of equipment. Is it a consumable? Yes. Does it have an on-usability? No. The on-usability ties into our gameplay ability system that we're using. So in this case, if I wanted to attach a firebolt ability when you use this item, that's what would happen. That's the way our Hearthstone is set up. So I'll show you that. Under unique. So our Hearthstone is common. I just have it set to food right now. It could be set to anything else. But it has an on-usability, which is a gameplay ability of our Hearthstone. So GA for gameplay ability Hearth. That will allow us to move around. That's pretty cool. But we're not looking at that. We want to look at stacking. So if I go and press play, we actually do have quantity set up. We have our items. Let me try hard to see. You can see that they do stack, right? We have 5 of bread and we have 5 of water. But if I try to give myself more starting items, you'll see that they won't automatically stack. So if I go to player states, I go to my player inventory. Again, this is the actor component that we've been working on. I have a starting item assets. It's a map of the assets that we want as well as the items. Because this is a map, I can't add more bread, but if I added another item of bread, they wouldn't stack on here. So, like, that's an issue. What we'd like to do is see if we can give ourselves 2 items and then stack them together. So I might convert this into a struct first. And then we'll just do an array versus a map. That way I could give myself 3 instances of bread, and then we can organize it that way. So what I'm saying, just to be a bit more clear, I think we're gonna make that into a structure, so I can, and then make a T array of structs. So basically I can have 2 bread spawn in here, and then we can practice our stacking logic. Oh, there's a problem there. Check this out. So if it drags to the same spot, it's not resetting the overlay, the drag overlay I have. And I think it's still calling to the server. Let's look at that. So we might need some logic here. Just gonna do a print statement for now, and we're gonna say item drop. I think this is still calling, so what we might want to do So, what we need to do, before we attempt to do all this, we don't want to call the server to move an item if our slot, if this information is the same. So if our bag and slot index are the same, then we don't want to do that. So what we want to do is a couple comparators. So we're going to do a bool and we want to do an equals. We're gonna need a few of these, and this might be better to be a macro. I think we only need 2 of them. I'm gonna copy these, connect this. So what we want to do is check to see if our bag index and our source index, if they're the same, and if our item index is the same. If these 2 are the same, then we shouldn't move. If they're false, then we should move. So we need to print string, they dropped same slot. And here we're just gonna probably want to reset our drag overlay, it's called. So let's press play, just double check this logic. Yep, dropped into the same slot, perfect. So then what we can do is, I don't know, we have a function called reset drag overlay. So go compile and save that, press play. This should get rid of that gray. Yep, perfect. Okay, so we fixed that. Let me go delete this print statement. Don't really care about it. We can do that. I think this would be better off to be in a macro. We can call is same slot. And we'll paste this logic in here, and we're going to output that return value. This is going to need a index. Up inputs. We want this to be an int, and we're going to say source bag index. We'll say current bag index. I don't know if I like that. Add 2 more, and this is going to be source item slot index, and then we'll say current. This is destination, but item slot index. Let's do, yeah, dest. All right, this seems like a lot, but it's fine. So we'll do this, 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 this. We can delete these. This will be our macro. We're just going to return true or false. File and save. We'll go back into our on drop. Instead of this function here, we'll go to our macros. It looks basically the same, but it takes some of that logic away. Into our own custom node. That's how you make a macro. If you didn't know, is same slot. It compares and it outputs. So compile, save. We'll go back, press play, and we should reset our drag overlay. Perfect. And if we really wanted to, we could play a sound. We want, so I can just grab the sound here and we can play the sound. Perfect. Okay. All right, let's talk about stacking because that's something I want to do. I've been working on in a side project. So just so everybody knows, I've coded a lot of this before into another multiplayer project as I was testing out and trying to learn about replication. I think that's super crucial, and it was really important for me to understand how replications works at all. So if you see me copying and pasting some code, it's because I've written a lot of it already. And again, it's just in here. I can walk you through it. But some of the logic I've changed because I've changed and kind of cleaned up some things. But overall, I've kind of implemented some stacking before. So what we want to do is before we attempt to swap items, we want to try to stack items. So at this case, at this spot in our system, we have a valid item that we're trying to move. And here we just automatically swap them. So there's no thought about stacking at all. What we'd like to do is think through what it means to stack, what kind of information we need to have, and ensure that we actually have that information. And we want to try to stack it first. So we have a item to move. We then need to check to see if we have a destination item. So let's do this. Attempt to swap, or excuse me, stack item. So we need to check to see if the destination has an item, right? If the destination bag has an item in the slot that we're trying to go to. So we'll say check to see if the destination item in the slot. If we do, is it the same item? Can it stack? And does it have space to stack? Right? Those are the three things that we need to know. If there is an item that exists in that slot, is it the same item that we currently have? Is the item stackable? And then do we even have space to stack? So can my item stack in that space? Those are the things that we want to check. So the first thing that we need to do then is we need to get our destination item. So what we can do is do this. We'll say dest u item, dest item is equal to destination bag dot get item at index. And we're going to say destinations item slot index. Okay. Then we want to say if our destination item is valid and our dest item can stack. I think we want to say, we got to look this up. I think we want to say can stack with. So this checks to see if this item can stack, but then we also want to see if it can stack with a specific item. So if I go into my base item, we can see, let's see, we have a helper function. Can stack, we just return if it can stack, but we want something that says, can we stack with? I think that's more important. And I thought maybe I had written it. Maybe it's on, yeah, can stack with. So let's go to this so what we're doing here, our can stack with. So this is going to check to see if we can stack with a specific item. Can we stack and can we stack with a specific item? So this says return true or false. We're going to return a boolean. So we're going to return true if our item that we're trying to stack with is valid, if the item's asset is valid, if the item asset's primary ID and this current item's primary ID is valid, and if our current item can stack, and if our quantity is less than our get max stack size. So there's a lot of things going in here, but it's saying, hey, can this thing stack? This might be doing too much, and I'm going to make a comment about this. Specifically this one, I think we don't want this and statement because we can stack regardless if the max stack size is too big. We'll just have to figure out what size is like available to us. But we'll leave this for now, knowing that this might become a problem. All right, so we're gonna say can stack with, and we're gonna pass in our item, our destination item. Sorry, our source item. What do we call it? Our origin item. Sorry, our origin item. If these two things are true, then we know that we can we want to attempt to stack. So the first thing that we want to do is get the available space, which is actually going to be a constant in 32, and we'll say available stack space is going to be equal to our destination item we need to get current quantity. So we could say quantity, but it's minus its total stack size. So we want to get the available space. So if the item has a stack size of 20, but it has 2, that means available space is really 18. So we need to get that value. And I think what we can do that is through a helper function. So we're going to say int 32 get available stack space const, and we're going to return we need to always make sure our item asset is here. If that's true, we'll return that. If it's false, we'll just return 0, meaning it can't stack. It's a little bit safer. I need to do this as a cleanup and go through and kind of clean up most of this stuff. So we're going to say to do cleanup assets, item, asset, access to ensure minimal crashes. We don't want to have a null pointer reference crash here. So now that we have that get available stack space, what we can do here is say destination item get available bag space. We know we're going to return an int. It's constant. We don't want to edit it. Perfect. From there, we want to check to see if that available backspace is greater than 0. If so, that means that we can attempt to stack. So we can say if available stack space is greater than 0, then what do we want to do? Well, then we want to figure out the number, the amount that we can move. Is like we want to check to see, so if our item has available space of 10 but our item has 12, we need to get that value that we can do. There'd be like 2 left over, so we're going to say const int 32 amount, like amount it's quantity move, we'll say amount to move is going to be equal to f math the min, we're going to get the minimum between 2 of our origin item quantity versus our available space. So what this is going to do, this is going to return the minimum value between these two. So if you didn't know what math min does, it just returns the minimum value between the two. So once we do that, we want to add quantity and remove quantity from different things. And I don't think I have that functionality built into my items yet. So like we want to say destination item. So now we're going to be actually stacking. So we're going to say destination add quantity, which we don't have. And then we need to remove that quantity from our origin item. Now, these functions don't exist yet, so we're going to go ahead and add them. We could create one function that's like update quantity, and you can just say if it's minus or plus. I like to be a little bit more verbose when I'm doing this because I feel like it's a little bit more helpful when I come back later to read what I'm doing. So back in our base item, we're going to add some ints. These would just be voids actually. And we're going to say add quantity. This is going to be int 32 amount. And we're going to do the same thing here where we'll say remove. Okay. We want to add the definitions. I'm just hitting Alt Enter on my keyboard really fast. That just in Writer does it. If you didn't know. Okay, so now that we have that, what we want to do is just quickly add to the quantity. There needs to be a check in here, I think, though, just to ensure that we don't go over it. But I'm gonna think we already check it here, so we can never add too much more. I'm gonna add a comment here. To do amount. To do enforce stack max stack size. I think we need to do that. My thought is we could take the if we can check to see here if quantity is greater than our item asset. Okay, you literally have a get max stack size. If that's true, then we can say UE log fmt log item error quantity attempting to add an amount above max for item and we'll set quantity equal to max. So this is a pretty big error and we should not let this happen. If it does happen, I'm going to set it to the max stack size and we'll lose an item. But this should not happen. So I probably need to clean this up a little bit, but for now, it's going to be okay. Okay. Now what we want to do, that's for adding. For removing, we want to subtract, and we want to say quantity is going to be equal to f math. Again, we want to do the max instead of the min, and we're going to say 0 or quantity minus the amount. So this just enforces that our quantity will go from 1 to 0, a max to 0. Right? We never want to go to -1. Pretty self-explanatory. Here we'll add our reference, the pointer, and then we need to add the amount that we want to do. Those add and remove, so it's going to be amount to move. There we go. The last thing that we want to do, or one thing we want to do, is say if our origin item quantity is less than or equal to 0. Should never be less than, but we'll just double check. If it is, we need to remove the item. So we're going to say origin bag dot. I don't think I have remove item yet. Interesting, I added. Look at remove quantity. Oh, I'm sorry. Yep. Okay. We want to remove remove quantity as part of the base item in origin bags and items. That's like, where is that coming from? Okay. We want to remove the item from the bag and then remove it from our sub replicated object list. So inside our bag, I think I want to add a bool remove item. We want to first check to see if our inventory dot contains item. If it does, then we'll remove it. Item inventory dot remove item. So we can use this statement if we want. Right now I'm just going to say dot remove item and we'll pass in origin item. And then we need to say remove, it's called remove replicated subobject, and we'll say origin item. And you know, I just realized this is wrong. So we want to make sure it contains it. We actually don't want to remove this item. Now I'm thinking about it. We want to set. We never want to remove anything because we're switching between a null pointer versus adding an item. We don't actually want to remove it from the array because that changes the size of the array. And if we change the size of the array, then we will actually replicate the entire array back to the client. We don't want to do that. So we actually want to something different. We want to say get index. What is it? Index. What it is. Fine. Yeah, but does that sorry. I'm trying to think what I wanted to do. I think fine. We don't want to find it. We want to get the index of item. I guess we could pass in remove item. We can just remove the item at the index. So instead of u item, go back into and say we want to remove item at int. And then I'm going to capture this and this. And then honestly, this becomes less important. Sorry. Well, we can check to see here. We can do if item inventory dot is valid index. If it's a valid index, then what we'll do is we'll say item inventory null pointer. Item slot index bag is not valid. Forget. All right, that's better. Sorry. So what we're doing here is we actually want to get our item origin plot. So to recap, what I'm doing here is we don't want to remove the item itself. I don't want to resize the array. The array is set in the bag at the very beginning when we initialize our bag to the bag size, and we're just setting every slot in that bag to a null pointer. So we're allocating space in our array for the maximum size. So if the bag is 20, that means there's 20 null pointers inside our array. That way it's replicated to the client one time. And then when we change from null pointer to a valid item, then we'll replicate that one item, but we're not replicating the entire array every time. And so when we remove quote unquote something, we're not removing the item from the array, we're actually setting the slot to a null pointer. And in this case, we want to check first to see if the index that we're passing in is still valid. If it is, it should be, then we're going to set that index to nothing. And then we'll return true if we want to use that. I'm not returning that bool value for now, but it's okay. If the index is not valid, we want to output a warning, so I know I can kind of come back to it and figure out what's happening. So the other thing that we can do in here is say last updated slot index is going to be equal to this index, right? Because now we've done something at this slot, and that way it will replicate back to the client. The other interesting thing is when we add and remove quantity, we need to also update. So if I come into my item, and this is interesting because when we add and remove quantity, I think when we add and remove quantity, we don't have access to this last updated index. Or bag. Why is this one? Remove item. I don't know why it's saying that. There. Okay. That's just a writer problem. Uh, hmm. And this performs the stack. And this would just be our if our basically if our item is if okay. I want to do one thing before we get too much further. So I have this map of starting item assets. I want to move this into an array. No. What I'll do, I want to be able to add another stack of bread pretty easily, and I'm pretty sure I can do that inside my starting items thing. So let's go down to where we're doing that. We have give starting items. I'll give myself another bag. So what we can do is create items. I'm just gonna do a thing in here. If new item dot get type. It's a drink. We're gonna add the item again. Okay. So this should add water for us twice. Let me restart, make sure we didn't break anything crazy, and then we'll pick up from here. Takes a second for it to build. What did I do wrong? Here we go. That was a stupid mistake. Oh well. We'll see how this works, and then we might leave it here for now. I might do a little bit more of this tomorrow. So let's compile, save. Let's see if we have our items. We have 2 water items. If I click and drag, I'm curious what happened here. It is valid, and we can move the items. Items to swap refreshing spring water. Items swap. So what I want to do here, back inside our up here, I kind of want to just return for now. I want to do u e log fmt log player inventory. I'm gonna copy this. Make this a log. I want to see what's happening. Items to move are the same. Tempting and can stack. That's first. Let's see what available space we have. So we'll say available. And we'll add this value. We'll say available stack space. And then I'm kind of curious. Let's see. Dest item quants. I'm going to grab it and we're going to do this. Quantity. Origin item dot. And before we do all this, which is totally fine, I want to we know it can stack. And then do this. Give me some more context to see what's happening. Just so I understand. I think I'm not too concerned. This is pretty complex stuff. So I'm gonna go to items, drink. Item can stack and stack up to 20. So we should be able to stack. We should see it go to 10. And we probably won't see it work. What I should have done actually before we do this, it might just be the UI not updating. We'll go to player state. We'll go to our player inventory. We're in bag 1. So here I have water, I think. Yep, spring water. And here. So here we have both of our spring waters. If I combine it, we can see that none of that information was actually replicated to our client. So we know that the swap isn't happening properly. So something's occurring. So we're going to control S to save in here. Save all. We'll recompile some of our new logic, and we added this return. There's going to be some more things we need to do, but we'll check this. See if our can stack with and everything works. We'll press play. And we'll test this out. We'll press play. Test it again. We have our 2 items. So items to move are the same and can stack. Available space to stack is 15, which is true. Destination item. So it looks like our quantity didn't work. So is it replicated would be my first question. It's on. Yep. Quantity is replicating. Quantity is replicating. This is a reference issue. I'm pretty sure. So I think think because I'm attempting to do this on pointer, I think I need a good. Or it's not replicating to the this is all server though, so it shouldn't matter here. It's interesting. Oh, you know what we could check? Maybe. One thing we want to do. Well, we know this is value is 15, but if this quantity is 0 for some reason, I don't know. I think it's good to do this. We'll press play. Restart it again, and we'll double check. Hopefully this works, or at least get us somewhere, a starting point for the next stream. So let's press play. We're kind of watching the log here. All right. So items to move, stack is 5, quantity before is 5, quantity after is 5, or 10. So that addition worked, but then the quantity didn't. And this is because we're editing the here. When I get the item at index, this is returning the. I need the reference. Is the issue. Let's see. I am a little confused on what's happening. We have I want to check to see if this. I'm like 1,000,000% sure the math is working along here. What I'm not sure about is obviously editing something wrong. Huh. I know I'm doing it on the server. Oh, interesting. Okay, what am I doing wrong? In the um. Just confuse myself. Hmm. What it's doing is the quantity before is 5, the quantity after is 10. So it added it, and then the quantity before is 10. It's like subtracting it from the other item. or it's adding it to. But these should be different items. A little stumped on this. Like, why is this origin item? This item has 10. I'm not sure what's wrong here. Sorry, I can't hear my music. Okay. Um, I'm a little stumped on what the issue is at the moment. It's something really stupid. I'm sure of it. But I'm a little stumped on what's happening. So the destination item we're adding, that's correct. But then we go to origin item, we say remove quantity, and we're saying that the quantity of our origin item is at 10 already. Let me grab this. Because to me, it seems like we're doing a we're like editing a different instance of the item or something. Yeah, it's like the stacking is happening, right? That logic is correct, but something with these pointers, I'm doing wrong. Maybe it's just can get item. Much to it. Okay. Yeah, why does it have 10? Oh, these weird bugs just take so much time. I mean, obviously it's something I did, but they're so frustrating because it's going to waste 30, 45 minutes, an hour to fix it. All right. Maybe I just need to take a break and come back to it to figure out what's happening. I'm not really sure. Okay. Too many debug statements then. All right, let's walk through it. We have our origin item. We know it's valid. We get that from our origin bag at the origin slot index. Now we're getting our destination item from our destination item slot index. From our destination bag. Which we got with our destination slot index. Okay. If that item is valid, it means it's not a null pointer, and it can stack with our origin item. Let's go to this. Oh, this just returns a Boolean value. We then say, so what I want to do, actually, let me grab that. What I want to do here is check our current quantities before we do anything. I'd be curious to see if anything really changes. If they both say 10, that's weird. They should both say 5, right? I think, man, I don't know. Get available stack speed. What's wrong? Maybe that's that. A little stumped on this one. Yeah, I feel like maybe it's easier to debug if you don't have. That's such a good point. It probably would be. Let's do that. That's a good idea. Yeah. That's a great idea. Thank you. I will add that and let's retest it. Appreciate that. That's an annoying little bug. But all right, so now we should have a stack of 5 and 2. Let's make sure that's working. Ah, that was a very helpful comment. Now we know there's a problem here. So the problem isn't like originating here. It's like the same item, which makes a lot of sense. Okay. Let's see. Attempted to add item. Or find first empty slot. That's peculiar. Oh, wait. I'm being stupid. I'm going on a tangent, and it's not even... That's working as intended. Okay. We're just setting all of them, if it's that one. I know what I'll do. It's freaking out for no reason. Okay. I think I had a whole bunch of other bugs, but we do not. Okay. So now we should have 2. There's a chance they're the same, but they're random for now. All right. And that's because I need to convert this to a struct. I don't want to do that right now. All right. You gotta be kidding. There is a bug there. All right. peculiar bug. Yeah, they're definitely the same item, and I think it has something to do with my add item function. Yeah, totally. Yeah, it's pointing to the same object, which is super interesting. And I haven't ran into that problem yet because I haven't been to the point where I'm stacking, and it doesn't matter with the swaps because I haven't had the same item in the bag. And I'm curious if it's an issue with. Yeah. Thanks for telling me to change the number though. That was extremely helpful. The other thought I was gonna do was compare the pointers and see if they're the same, meaning they're pointing to the same memory location, which clearly they are now. So, index. I'm thinking it's in here. So it's this. I want to say. I think it's returning an index here that is the same one. If I understand it correct, you have item and bag item. So it seems like there is two bag item with the same item. It's the same bag item with the same U item in it. And the way this is working is I call server add item. Oh. All right. We're going to do, I think this is the problem. Okay. Before I go on a huge tangent and change a bunch of stuff, let's do one thing. This is why. So what I need to do is I'm adding the same item. I create it one time. What I was trying to cheat here was after I created the item, I wanted to add the same item again. What I want to do is keep this logic, and I'm just going to create the struct that I want. So basically what I was doing, I was adding the same exact instance. So when I create a new U item instance from my item factory, it's creating the same exact item, or it's creating the one item, and then I'm just storing it in two memory locations instead of I'm storing the same instance, the same U object in two memory instances. So they're pointing to the same value. I don't know if that makes sense. So if I come into so it's like if I have an array of item 1, 2, and 3, when I'm let's call it actually U item 1, 2, and this is null. When I'm adding my item, so I'm creating item 3. Let me do this. I create item 3. And I'm pointing to both of these slots of that same item. Because these are pointers. So what I need to do is just create another item. Pretty simple. And this problem came up because I'm being lazy and did not want to create a structure to do my starting items, so I'm just gonna do that really fast. So we'll just do it. What is in here? Oh, you know, I don't even need that. There we go. Yeah. I knew it'd be a stupid little problem, but it's okay. So in my structures folder, I'm gonna create a new struct. We'll call this item. What is it? Item asset quantity pair. And then here we'll do an include item asset quantity pair generated use struct. Yeah. Oh well, not a big deal. All right. So here we want to have a U property blueprint type U property edits anywhere blueprint read write. This is going to be a U item asset. So instead of my map here, we're going to do a T array of U, F item asset quantity pairs. Can change our map a little bit, which is fine. So in here, we want to check to see if for each, that's true. We want to get the assets. If the item asset's not valid, then we don't want to do it. And then from here, we get our assets and our quantity. That way, now we can build as many things as we want of the same type, which I didn't have before. So go back to the original comment about let's use different quantities. This should work. Let's delete this. Okay. I think we're good. All right, let's test this out, and then I'll probably take a break. It's just in a bit. But let's see. Oh, we got a bug. What did I do wrong? Oh, I have an asset quantity pair somewhere. Oh, this project's gotten way too big. I bet it's in here. What is it pulling it? Okay, here we go. Literally the same thing. Okay. Easy enough. Already built this. Delete it. When did it pull from? Sorry about that. I think this is U base asset though. Okay. Oh, I was in the spot I wanted. So we'll go to player state. We'll go to our player inventory component, and we'll scroll down to our starting item assets. We can add a few assets in here. Let's do a Hearthstone. We'll give it 1. And then we'll just do the water. Canteen, I call it. We'll do it 2. And we'll do it 3. Oh, we have one more item. Bread. 5. Alright, there we go. 2, 3, 5. Let's see what happens with my stacking logic. Hey, look at that. We have stacking. Let me zoom in on this. That is clutch. That is a perfect spot to end the stream, I think. Alright. So we can move our items around. Move between bags. And then if I combine 2 and 3, we should have 5, which we do. So we have stacking. Look at that. Perfect. All right. Cool. Well, thank you very much. I will talk to y'all in the next stream. I might stream tomorrow a little bit more development on this, so please join me if you're around. Otherwise, I hope you all have a good day and talk to y'all later.